All right, and here's our conclusion to the translation series, where we're going to talk about what if we wanted to translate without a graph? How do you translate? How do you move something up and over when there's no graph to know how many units to count? So we're going to go back to the definition of a translation, and that was that it slides each point in the plane, number one, the same distance, number two, in the same direction. So if we only had something that could do both distance and direction. If we only had something.
Hi there, my name is Vector, or V with a little vector bar on top. I can do both distance and direction.
Really, Vector, that's fantastic. We need someone like you. But, I gotta say, you look an awful lot like someone we've dealt with before. Though his name was Ray. Do you know Ray at all?
Oh, Ray, yeah, he's my cousin. He only does distance, though, which is infinite.
That's true. Yeah, Ray was kind of like half a line where, one side was, a stop, there was an end point, and the other side just kept going on and on forever. Yeah, so, okay, tell me more.
Ray's arrow cap tells him to keep going forever, but mine is for direction.
So you're saying your arrow cap tells you to, just go in this general up and to the right direction?
Yeah, sure does. You got the idea. My direction could be this instead. Now I'm a different vector because of it.
So you look like you're the same distance, right? But, okay, so you're pointing the other way. Oh, so I see you got that little v vector prime. So that's how you're saying you're different.
That's right. My distance is from my tail to my arrow cap. The cap tells which way to go.
Oh, so your length really isn't infinite. It's not saying keep going on forever this direction. You're really just saying from your tail to your arrow cap, that's how far to move.
That's right. And you need to go in this direction, up and to the right.
I see. I see.
For example, point A is the pre-image and point B is the image under my vector. See? There. Look. Look at my tail. It's on A. And look at my arrow cap. It's on B. So from A to B, it moved along this direction, and it moved my exact length from my tail to my head.
I see. All right. So cool. All right. I gotcha. So let's use vector here.
That's me.
Do we need a little hand? Be like, hey, how you guys doing? Wave. Oh, it looks like he's giving me a middle finger. I better get that out there. Okay, sorry about that. Vector, were you giving us a middle finger?
No, my middle finger's just longer than the others.
Okay, that's what I thought. I just didn't want everybody to think, you were flipping off everybody.
Oh no, I love everyone.
See, that's what I thought, guys. Vector's not mean. He's cool. Okay, so we want to take segment AB and we want to translate it according to this vector. So we want to take this segment and move it and slide it this far and in that kind of slightly up and to the right direction. Okay, here's what we're going to need. We're going to need our compass and we're going to need our straight edge. Okay, so you can use your protractor. I think most of your protractors have the flat edge on it that you could use as a straight edge. So we've done this before. Okay, we just haven't literally applied it to this situation. So we have done this previously in the construction chapter. So what we're going to need to do first is you need to use your straight edge. And first we're going to translate A. Okay, so take your straight edge and connect A to the tail. And I don't think it really matters, but we're just going to do it to the tail of our vector V. Okay, so what we're doing right now is we're making a transversal. We're going to use this, our vector, as one line, and then from A, we're going to make a parallel line. But we need to make it this specific length. So that's where our compass is going to come into play to get this exact distance and come down here and match it. Okay, so first, again, and this would be a good idea as you guys are taking notes. You might off to the side or down below somewhere make a list of what we did first. So you might say, not this, make line from A to tail of vector. Because I think that's one issue a lot of you are having. You can do this stuff when we go through the video, but then the next day in class you're like, oh, I don't know how to do this. I could do it yesterday, but I don't know how to do it now. So as we're going through these, you probably want to keep a list of the steps that you were doing so that tomorrow, whenever you practice these more, you can go back and refer to that list. I think that'd be an excellent idea. So one, again, we're going to make a line from our point A to the tail of the vector. Okay, and we're going to go beyond it even. Okay, so don't just stop at the tail, keep going past it. Okay, so that was step one. Now what we need is we need our compass. All right, and what we're going to do is we're going to copy this angle. It's been a little while since we've done this, but we're going to take this angle and we want to copy it down here. Okay, so that we're going to get the direction part down pat. So take your compass, put the pointed end right here at the tail, and now you can set the compass to whatever length you want, but you don't want to make it too crazy. Okay, make it big enough where it's going to cross the vector and it's going to cross this line that we initially made. Okay, so go ahead and make a sweep there so that you can see where it crosses in both of these cases here. All right, then take your compass, come down here, put the pointed end on, if I can get it there. Need to shorten this down just a smidge. Decrease length. Put the pointed end on A. If I can get it exactly on A there. There we go. And again, same setting here, same distance. Make another sweep down here. Okay, so this sweep and this sweep should be exactly the same. They don't have to be the exact same length because this one I went a little longer than I did that, but that's okay. Okay, next step, still using the same, or not same length here, but we're going to go up and put our compass up on this point that's up here. Okay, and I need to set the compass to be this width. Okay, setting my compass to be that distance there. So I'm going to grab a different color here. And if I swept through, you'll notice I crossed over right there, right where that was at. Now, using that, I'm going to come down here, and we're going to do the same thing. Okay, my compass point was right here. Now I'm going to slide it down and put it on that upper end. And again, we're going to see where it's going to cross. Now, notice over here, where those two things crossed, that's where our vector was. So where these two arcs cross, there's where our parallel vector is going to be. Okay, so now what we want to do, let's get blue. You want to use your straight edge and connect A to this point of intersection and go beyond. So we want to make something like that. So our vector V and this new segment that we've created, this new line or this new ray, whatever you want to call it, should be parallel to our vector. Okay? So at this point, what I'm going to do is erase all of my arc marks that I currently have. Okay? And at this point, I really don't need this anymore. Now what I need to do is take my compass, put it on the tail of the vector. Oh, poo. Try this again. There we go. And now I need to set my compass, set the distance. Set the distance, there we go, to be the length. I need the distance of this vector now. Okay, so notice I've got my compass to be that length. And now I'm going to take the same distance, come down here, put the pointed end on A, and then I'm going to make a little arc. Now, where those two things have come together, right there, there is A prime. So now, erase that little arc mark. We no longer need this line anymore. Oh, there we go. Don't need that anymore. So now, here's what I'm just going to check real quick. Did A move to A prime in this same general direction, kind of uppish to the right, and did it move this exact length? So what I'm going to do to check that out is this is easy for me to do, not so much for you guys. But I'm going to move this vector and see if it fits exactly between A and A prime. Okay, and then later I'll undo my move so I know exactly where it went. So if I come down here, let's see, did I do it good? I think I did it pretty well. My tail end, notice, is down there is on A, and my arrow cap is right on top of A prime. So that looks pretty good. So I'll undo that so it goes right back where it was before. And now we get to do it with B. All right, so starting all over again, first step. And again, hopefully you guys are taking some notes as we're doing this. I'm not going to write everything out. You can kind of write it in your own words. So again, from now B over to the tail, I'm going to make a ray, a line, a segment, whatever you want to call it here. And I'm probably going to have to move this up a little bit just so I can get to some stuff here. So now we've made our transversal. Now we want to try to make our parallel line. To first do that, we need to create matching angles. So put the end of your compass up here on the tail end of your vector. And then again, you get to set the distance. It doesn't have to be anything particular. I don't want to make it too big, so maybe I'll make it right there. And then sweep through to see where it crosses at both of these spots here. Okay. Now, same compass setting, come down here and put the pointed end on B and make another big sweeping arc. Okay. So really, if you think about it, if I finished making that circle and finished making this circle, they would be the exact same size, where this tail end of the vector is the center of that circle and point B is the center of this circle down here. Okay. Now, point it in on, let's say, this upper point up here. And now set your compass to be this distance between this point and this point that we made with our arc. Okay, we need to set that distance. And if you want to put a little mark there, you can. It's not really necessary, just to kind of double check and go, yeah, look, it goes through that point. Now, same setting, don't move it. Come down here and put the pointed end on that upper point right there. And then we're going to make an arc to see where they cross. And we see that they cross right there. Okay, so this point here is kind of like this point there, if you will. Now, where those two crossed, we had our vector go through. So where these two cross, we need our kind of parallel vector, if you will. So you need to use your straight edge. And from B, go out towards that point, go through it, but keep going a little bit beyond it. So this vector and this vector should be parallel if we've done everything correct. So now at this point, let's erase and get rid of all of our extra stuff. So we don't need these arcs anymore. We don't need these arcs up here anymore. We're actually done with this line. We don't need U plus sign anymore. And there's no plus sign here. Nope, didn't move it. I'll just leave it. Okay, so now finally, now that we have our parallel vector, we need it to be the same length down here. So this is where we're going to use our compass one more time. Put it on the tail of the vector. Swing it up, and let's set the distance. What do you think? I think we're pretty good there. Come down here. Make a sweep. And then we're done with this. We don't need that anymore. We're done with, well, let's see, let's make our point first. Let's get orange. So right there, where all that came together, that should be B prime. And so now we don't need that point anymore. We don't need that anymore. And we don't need this anymore. So last but not least, let's connect together A to B prime. And again, let me check. Is this distance from B to B prime matching up exactly with this vector? And you can see I'm a little bit off, and it's probably just because of, my compass work. Maybe I didn't get the end of the compass exactly on a specific point. Your guys' stuff might be a little bit off like this too, but don't worry too much about it. So my A was pretty much spot on. My B was a little bit off. Okay, but in general, does it look like that all of these points from A all the way down to B get moved the same distance in the same direction? For the most part, it's pretty close. Okay, so this is just even to show you that I can be off a little bit for whenever I do this stuff. Now, if let's make an extreme case here. Let's say yours looked more like this. Then I know we've got an issue because this slope, if you will, should be repeated over here. And if I can look at this and definitely tell that it's absolutely a different slope, then I know you're not really getting it there. Okay, so that's all I'm going to do in this video. It's just one example, but I repeated it twice. So hopefully tomorrow in class you can practice a little bit more, and then future worksheets that we'll do in class, we'll still have some more translation stuff, so you can continue to practice on those. So that is all for the translation series. The next series we will explore will be our one and only non-isometric transformer, dilator. So that is all. Adios and goodbye.